I spent the last 8 months making a Joseon Dynasty throne room in Minecraft, just so I could take it apart and understand how it works. Hold on, who recreates a real-life building in Minecraft just to understand how it was made? Well, all the way back in June, when my summer break had just started, my friend DM'd me on Discord telling me to play on an Earth Survival Minecraft server with him. So I got on, and decided to start building a Korean house in Antarctica. I was really proud of the house's appearance, but the more I looked at it, the more I realized that I didn't actually understand anything about how the house functioned. So I started to research Korean houses, and that sent me down a rabbit hole into Korean architecture, and I discovered the Geunjeongjeon throne room in Seoul. I immediately fell in love with how it looked, and like any builder, I wanted to understand how it was made. So I spent the next 8 months building my own throne room inspired by it to truly understand how it works. When you look at this building, the part of it that instantly stands out is the roof. At first glance, it doesn't even look like a roof this big can sit on such a small structure. But this roof isn't just for show. The massive overhang prevents rain from hitting the walls, protecting the wood from water damage. The iconic upturned parts of the roof in the corners are known as flying eaves, and they allow for the building to receive more sunlight during the winter and less sunlight during the summer. During the summer, the angle of the sun is at its highest in the sky. Because of that, the light from the sun ends up hitting the roof and doesn't go into the windows. During the winter, however, the angle of the sun is lower in the sky, and sunlight is able to go into the interior from under the eaves, which provides some well-needed warmth during cold winter months. So now that we've understood the function of the roof, let's see how it's actually made. The first part of the roof is the wall frame, which acts as the base for everything above. After the wall frame come these wooden brackets that begin distributing the weight of the roof evenly. Then, wooden beams extend outwards from the structure and form the support for the first eave. This creates the inner eave, which provides the first layer of protection for the building from the environment. Repeating the pattern, another frame is added on top of the first eave. However, this second layer does not use wooden brackets like the first layer. Instead, the wooden beams are placed without support below them. This forms the outer eave, also known as the double eave, which gives the roof its dramatic overhang and creates the floating roof effect. Finally, heavy roof tiles are placed to complete the roof. So what may look like a singular roof is actually a layered system, where each part works independently to help distribute the weight. If you were watching the roof assembly process closely, you might have noticed these wooden brackets extending out of the structure. These brackets are known in Korean as gongpo, and their purpose is to distribute the massive weight of the roof down to the columns below. So let's see how they're made. As it's being assembled, the first thing you'll notice is that these brackets are not a single entity, but are instead a system of multiple interlocking parts. And these parts aren't held together by nails. Traditional Korean buildings use wood joinery, meaning that every piece is carefully carved to interlock with other pieces without nails. Since wood naturally contracts and expands with changes in humidity, these joints aren't rigid. In fact, as more weight is added from above, the pieces press more tightly into one another, which increases friction and makes the entire structure even more stable. As more and more pieces are added, the bracket grows outwards and upwards, stepping out layer by layer. This prevents long sections from being left unsupported, since every extension is reinforced almost immediately by another element beneath it or beside it. Once the brackets are completed, the wooden beams that form the roof are placed on top of them. And the end result is exactly what has fascinated me in the first place. It's a piece of a building that looks incredibly complicated and unnecessary, but it's actually crucial to the structure and makes a lot of sense once you understand how every small piece plays its role. But not all gongpo are the same. In Korean architecture, there are two different styles of gongpo: Jusimpo style and Dapo style. In Jusimpo style, the brackets are only placed on top of the wooden columns, not in between them. This style was primarily used in the Goryeo dynasty for smaller temples and memorial halls that had lighter roof loads. The second style is Dapo. Unlike Jusimpo style, the brackets in Dapo style are placed both on top of the columns and in between them, creating a much denser and complex system. This style became an icon of the Joseon dynasty and was mainly used for grand structures with heavy roofs. This throne remains of the Dapo Gongpo style, which is better suited for the load of the massive roof, and visually, it creates a much richer appearance than Jusimpo style does. The repetition of the brackets adds rhythm to the building, whilst also subconsciously reinforcing the illusion of the floating roof. Even though the Gongpo brackets can carry the massive weight of the roof, that weight has to end up somewhere. And that's where the wooden columns come in. These columns that form the frame of the walls are what transfers the weight of the roof to the stone foundation, which holds up the entire structure. But if you look inwards, you might also realize something else. All of the wooden columns are arranged in a grid that neatly organizes the interior. Each space between 4 columns forms what's known as a bay, which divides the building into smaller structural units. These units allow for the weight of the roof to be distributed more evenly, whilst also laying down a framework for the floor plan. If you were to look at the columns even more closely, you will see that they aren't perfectly straight. They actually taper slightly as they rise. That tiny detail makes the structure feel significantly lighter underneath the heavy roof above. But no matter how well designed the structure is, its weight still has to be supported at the ground level. And that's where the stone foundation comes into play. This entire building is supported by a huge stone foundation, known as a WorldEdit in Korean. The foundation serves the purpose of taking the weight of the building and distributing it across an area wider than the area of the building itself, making the structure much more stable. It also acts as a barrier between the wooden portion and the earth. That separation is really important, because without it, the wood would start to deteriorate over time. The foundation also elevates the throne room above its surroundings, creating a sense of awe and reverence in visitors meeting the king. In the past, the king of the Joseon dynasty would appear on the platform to address officials or conduct ceremonies, with the elevation reinforcing his authority. So from the roof all the way down to the foundation, every part of this building was carefully designed to work together. What looked like an extremely complicated structure that was impossible to make actually made a lot of sense when I broke it down and looked at each part separately. This build taught me a lot about how these structures work, and I hope it taught you too. If you want to see more videos like this, make sure to drop a like and subscribe. Thanks for watching.